So in the today's class, we are going to discuss uh, next set of a bearing materials called a non-metallic bearing materials. It's a non-metallic bearing materials means here we are not using a metallic one. It's purely a non-metallic bearing materials. So these non-metallic bearing materials provides a variety of property that are suitable for large number of applications. They generally use for a low PV and means pressure, velocity, a value applications due to their relative lower heat conductivity. Means when compared to the metal, these non-metallic bearing materials are a less in heat conductivity because they are very sensitive with the heat. When the heat changes, it will going to change its properties. Means the thermal conductivity, of course, it's very less as well as a thermal expansion is very high. Take an example of plastic, plastic or rubber. What happens if you change the heat? If you change the heat, what happens? Plastic or rubber? If you change the heat or if you increase the heat, what happens? It will start melt. Plastic, correct? So, in the non-metallic materials, they are very sensitive with the heat, okay, temperature. That's why they are using for a less pressure velocity ratios. And of course, they have some other important properties like they are self lubrication. When compared to the metals, these plastics and rubbers having a self lubrication. They are having a property self lubrication. Of course, they are very low cost, correct? They are very low cost. Take an example of polymers. They are very low cost compared to the metals. And chemical resistance and high temperature suitable requirements in the non-metallic bearing such as examples plastics, ceramics, rubber, carbon graphite and other materials. So examples are the plastic, ceramics, rubber, carbon graphite, even nylon, Teflon. So these are all a example for a non-metallic bearings. So in that first important one, a rubber as a bearing material. So rubber, we already know that it is purely a non-metal. Rubber is a purely a non-metal, and these non-metals are generally non-metal bearing materials are generally used for high load applications. They are used for high load application because they are having a very high compressive strength, they are having high compressive strength, fatigue strength. But these non-metals are relatively compared to metals, they are having a less load carry capacity. But other than that, they are having a non-corrosive. When compared to the metals, they are purely a non-corrosive. Of course, here where it is very high when compared to metal. So some advantage is there, some drawback is there. But these non-metals where we are using means where we need a particular application, like it's a high temperature application. In that we are going with the ceramics. Ceramics are the high temperature applications we are easily used. So like that very particular applications we are using this non-metal bearing materials. In that first one is a rubber bearing. It's a rubber bearing. It is used where quiet operations is required. Means very noisy operation where the noisy operation is there. Okay. In that we have to replace that noisy operation. We are using with this rubber. So the rubber, if used as a bearing material, it won't produce any noise. It's a very smooth applications, and it is a large clearance and misalignment encoder. When the large misalignment, if any large misalignment or a large clearance required, we are using this non-metal means rubber as a bearing material. Means it will absorb the misalignment. It will absorb the misalignment. Okay. Next, it is found in the bearings for a profiler, rubber shaft, boat and ships. We already know that boat and ships are used in the water where the moisture is there. So this rubber is purely a corrosion resistant. Okay, that's why it is main used in a rubber shaft or profiler in the boat and ships. Ships and boat profiler or shaft that made by this a non-metallic rubber bearing material, and it is found where water acts as a lubricant. If you use water as a lubricant means in that we are using this rubber as a bearing material because it won't produce any corrosion. If you use any metal material, what happens? Water is a lubricant, so it produces corrosion, correct? So we are using rubber as a bearing material. It completely eliminates the rust or corrosion. That's where the water is used as a lubricant. In that we are using this rubber as a bearing material. Okay. And this rubber is very slippery as it is used such as situations reduce the friction. Here the friction is very less because this rubber itself a lubricant, and also rubber is a very slippery in nature, so that it prevents the friction, or it nearly reduces the friction. So this rubber having a lot of advantage, at the same time it is having a lot of disadvantage. Okay. So the one important non-metal material is rubber. The second important non-metal bearing material is carbon graphite. So carbon graphite, we already know that they are non-metals. Carbon graphite. Is it correct? Carbon graphite is a non-metal. A carbon, of course, it is present in the 90%, more than 90% in the steel. What is the constituent of steel or ferrous? Carbon. It is having a more than 90% carbon. But here, carbon graphite, it used as a non-metal. Okay. So non-metal bearing materials. It is used for food handling equipments and in the textile industries because of self-lubricating property. No additional lubricant is required, hence limiting lubricant contamination prospects. Since this is a resistance to the corrosion, it used even in the water. Of course, all these bearing materials are corrosion resistance. It is the one advantage. Okay, where the water is used as a lubricant. It's a one common application. And here this carbon graphite is used as a food handling equipments and textile industries, where the textile industries and food handling equipments, okay, refrigerators, okay, storage devices, in that they are using this carbon graphite as a bearing material. Okay, it won't produce any toxic, because food handling equipments need a, it's free from the toxic material. Once, because if they are toxic, it may destroy the food. Okay, so it may free from toxic. That's why it is used in the food handling equipments as well as textile industries. Of course, textile industry also very sensitive, means if they are toxic, it may harms the clothes. Okay, so it is free from the toxic. And the other advantages are they are self lubricating. These are self lubricating. There is no external lubricant for reducing the friction. Here friction itself is less because they are self lubricating materials. And the next important material is Teflon. Okay, so Teflon, I heard Teflon, it is also called as PTFE, means polytetrafluoroethane. Polytetrafluoroethane, it is commonly called as a Teflon. It's an another type of polymers. It is purely a polymers. Polymer means more than a single link. Polymer means they are having a links which are more than single link. Okay, polymer. Kelidra, polymers means many links. Poly means many links. Many links is called as a polymers. In that, there are different types: ladder type, cross type, chain type. Ever there are different types of polymers, and that polymers are again classified thermoplastics and thermocytes. Thermoplastic and thermocytes. Ever, so thermoplastic means they are, once the heat increases they will melt. Once heat reduces they become hard. But thermoset means once they change means it is permanent. The change is permanent, means in that there is a cross link or ladder type links are there. Once they are deformed means it is final. Again, if you increase the temperature, they won't melt, they will simply destroy. That is thermosets and thermoplastics. Here this Teflon is also one type of polymers. Okay, and it is another type of plastics which are self lubricating. Of course, all these are self lubricating properties and a low friction. If they are self lubricating, obviously they produce the low friction. However, these having a drawback like a poor strength. They having a poor load carrying capacity. Correct? These non-metals having a less load carrying capacity, poor strength, and low wear resistance. When compared to the ceramics or when compared to the metals, the wear rate in the plastics are more. The wear rate in the rubber is more. So this is what the drawback. And reinforcing with the fibers improve the strength. And these Teflons or plastics are reinforced with the fibers. If you reinforce with fibers, they increase the strength. That is what composite materials. If used as this composite materials, they are having some advantage, because plastic is having these are drawbacks. If you use this plastic, these are the drawbacks. Okay. If you use along with this plastic, if you use some fibers, a graphite fiber, armored fiber, any advanced fiber, along with that, it will improve the properties. It will improve the load carrying property. It will improve the wear resistance property. And these properties we can enhance by using these fibers. Along with plastic, if you use fibers, it will improve. Simply, if you use composite materials, composite means matrix and reinforcement. Here also same thing. This is a matrix and this is a reinforcement fiber. If you use these two, it will increase the strength as well as wear resistance properties. Okay, and the main advantage is they are very lightweight compared to the metals. And the next type of materials is phenolic plastic bearings. The phenolic plastics bearings, and these you just note on the headings. Heading note ಮಾಡ್ಕೊಳ್ರಿ. Okay, and I will share the notes, no problem. And this phenolic plastic bearings, they mainly laminated phenolics are formed by treating sheets of either paper or cotton fabric with asbestos or other filler materials bonded using phenolic resin. Means these phenolic plastic bearings are used as laminates. Have you heard laminates? Laminate, huh? Laminated uh, sheets in the advertisement. I think you heard. It's a laminated sheet. What is meant by laminate, or what is meant by lamina? I think you heard the word laminate. Huh? The plywood. It is a laminate plywood. What is what is that meaning? What is laminate? Laminate means it is a stacking of lamina is called laminate. Okay, but what is meant by lamina? A lamina means it's a single block. It's a single block used for laminas is called laminate. Lamina. Okay, lamina means just take an example of wall. Okay, so this wall is completely made by no wall, not RCC. If it is RCC, it is concrete. What about this wall? Wall is made by bricks. Okay, that single brick is called lamina. Okay, this entire wall is called laminate. Okay, so wall is made by n number of bricks. A single brick stacking on another stack of bricks is called wall. Okay, a similar way, a lamina means just like a brick. It's a single lamina which is made by reinforcement and matrix material. Reinforcement and matrix material. It's a single block is called lamina. If n number of laminas stack each other, then it is become a laminate. Okay, the plywoods are the best example for laminates. Plywoods, a single layer of laminas first they placed, again reinforcement, sorry matrix, then another layer, then matrix, then another layer, just like a paper. Okay, paper means it's a lamina, a one paper. Okay, and applying the rubber and placing another paper, again applying the rubber, sorry, gum, and placing the another paper. Like this, if you place, what happens? It will increase the thickness. Correct? If it is a single paper, it may be less than 1 mm. If you stack one paper on another, it will become increase the thickness. You can achieve 10 mm, 20 mm, 30 mm. Correct? You just place the paper, what happens? You cannot use for anything. If you just place the paper, just placing it without applying any gum, what happens? What happens? Just take your book. It can use for anything. Use Modboda. It's not possible. Instead of just placing, if you apply some gum and bond each other, what happens? Then you can use it for anything. Correct? Just laminates or your plywoods also same thing. Okay, they are used a laminas and applying the epoxies or resins, then placing again lamina and applying the epoxy means gum. Okay, and applying. So like this it will forms the laminates, and those laminates can use for again roofing purpose, again furniture purpose, again for the board carpentry we can use it. Clear? Because they provides the good strength, okay, good aesthetic look, everything is good. That's why they are used for either furniture purpose or carpentry purpose. Clear? Here also same thing, we are using laminates. Laminates means these phenolic plastics. They are not using only a plastic, they are stacking of laminas with other, they forms the laminates, and those laminates we can use for our aircraft applications, aircraft landing gear, in several applications where water is a lubricant, such as rolling mills where water is used as a cooling lubricant. So these are also used in the centrifugal pumps. The centrifugal pumps or aircraft landing gates. In these conditions, we are using these laminated or stacking of. That means we can obtain the desired thickness. Laminates means we can control the thickness. If you want 5 mm, we can only get the 5 mm. If you want 10 mm, we can get the 10 mm. Just by stacking the laminas. If you want 100 mm, we can achieve the 100 mm by stacking the laminas. Okay. So these thickness we can control, and that can use for aircraft landing gear. So aircraft landing, I think you've seen when the aircraft comes into touch with the ground, what happens? What happens? Because of the heavy thrust. Already aircraft is having a load, okay, and also they are moving in the heavy speed. So it generates the heavy thrust. Once that come into contact with the earth, what happens? There is a sudden load applied on the components that should be absorbed. Okay, that landing gates, okay, that landing gates will absorb the vibrations. That deformations are that vibrations may in terms of 10 20 mm, 10 mm, 20 mm or 30 mm like this. Okay, that much of vibrations, and those absorbed by uh, a materials. Okay, and these landing gears which are absorbs the vibrations, and here we are using the bearings. Those bearings are made by this stacking of plastic materials. Okay, laminates. Is it clear? It's an important material. And after that, another set of material is nylon. Have you heard nylon? It is also a polymer. Nylon is also a polymer. It's a crystalline material widely used for bearing materials as sintered layer inside with a metal sleeves or injection mold sleeves, and it's an excellent, this nylon is an excellent toughness, means it is used as a multi-layered, a one base metal is there, on that this nylon is going to cool. Okay, so this nylon used as a bearing material, it provide an excellent toughness. Toughness means ability to absorb the distortion energy, ability to absorb the distortion energy or energy produced by the some sort of vibrations. Okay, that is what toughness. This wear characteristics again varies very less if you use nylon as a material, and fatigue and chemical resistance. It's having an fatigue and chemical resistance. Nylon bearing is commonly used in light loaded applications such as household appliances. Okay, and it is with a self lubricating property. Of course, it is used as a bearing material. Clear? So this nylon, phenolic plastics, Teflon, these are all a type of polymers. And if you use this polymers as a bearing material, what are its advantages? So these are the some advantages if you use this polymer as a bearing material. This only a polymers, okay, not ceramics. Next we will discuss the ceramics. This is only a polymer as a bearing material. So here it's low starting and low running friction. Of course, they are self-lubricating. That's why a low starting and running friction. Friction is very less. And friction obtained in case of a sliding bearing, in case of a full film lubrication. Just like a full film lubrication, we already discussed in our in the beginning classes. There are three important types of lubrication: perfect lubrication, thin lubrication, and extreme boundary lubrication. ಒಂದು ಕೇಳಿದ್ರಲ್ಲ ಆನ್ಲೈನ್ ಕ್ಲಾಸಸ್ ಅಲ್ಲಿ we discussed perfect lubrication, thin lubrication, and extreme boundary lubrication. If always the bearing should operate under perfect lubrication, but it is highly impossible. It is may operating under thin film lubrication. Okay, in those thin lubrications, only friction is fluid film lubrication. There is no friction because of contact. There is no contact friction. Only friction is because of lubricant. Lubricant will afford the friction. Okay. Here also same thing. In case of this, the friction from the outside is very less. For the self lubricating, they may produce the fluid film friction. Okay. And the second advantage, and also they are less cost. And second, ability to withstand mandatory shock loads. They can withstand the shock loads because they are polymers are rubber, and these rubbers and plastics mainly used for absorb the shocks. Correct? They are used as a dampers. Correct? Rubber. So their ability to absorb the shocks. It's an advantage. Next, accuracy of a shaft alignment. Alignment means the point of contact. If the point of contact increases, then alignment, there is a misalignment between the shaft and the bearing. So bearing is also a circular, shaft is also circular, and these having a center point. If the center point of bearing and the center point of shaft lies with the same, then there is a perfect alignment. There is no eccentricity. If the eccentricity come into picture, it increases, they may increase the contact between the bearing and the gel. That is what the misalignment. Here it avoids the misalignment. If you use polymers as a bearing material. A low cost maintenance and no need of lubrication. We already know that they are self-lubricating. So low cost and no need of lubricants. And rolling bearings gives an warning prior to the failure. Means if you use these as a bearing material, before going to failure, they will give the indication. They give the warnings. Okay, that is another advantage. So that we can stop the operation or we can replace the component. Next, reliability of services. Reliability means we can trust. We can trust these materials, these polymers as a bearing material. Means we can expect the life cycle. If we want, we can use for 2 years. We can easily use for 2 years. After the 2 years, we can replace. That is what the reliability. We can easily reliable on the component. Easy to mount and erect means you can easily mount. Wherever we need, we can easily mount these bearings. Mount and operate these bearings. And cleanness. They are self-lubricating so that they won't produce any contaminants or dirt particles. They are very clean. So these are all advantages of if you use polymers as a bearing material. And similarly, at the same time, they are having some disadvantages. Like advantages, they are having some disadvantages. Of course, more noisy at very high speed. If you increase the speed, they become more noisy. But preferably, these are used for moderate speed or low speed applications. And low resistance of shock loadings and more initial cost and design of bearing Housing is complicated. Means the complicate means the designing of these bearings are complicated. Okay, we have to see the factor of safety, everything, and design may complicate. Okay, and more initial cost means if you use uh, laminates laminates as a bearing material, the cost itself will increase because they need a n number of laminates. Lamina means it is a combination of matrix and reinforcement. They itself a cost. Okay, so that they may increase the initial cost. If you use rubber, they reduce the initial cost, but if you use that different types of polymers, they increase the cost. Clear? So these are the advantages as well as disadvantages of this polymer bearings. So next set of bearing is in the non-metallic ceramics. A ceramic bearings. Have you heard ceramics? They are ceramics are the graphites, carbides, oxides of metals. Okay, that is what ceramics. Here, significant benefits for the regular steel bearings. If we compare with these ceramics, when compared to the steel, they are having a very advantageous. The properties of ceramics impart bearings includes the superior intensity, better high temperature resistance, superior corrosion absorption resistance, outstanding magnetic and electric insulation. Ceramics are completely non-magnetic, and also they are very least respond with the temperature, so that wear resistance is also very high. They having wear high resistance means the wear rate is very less. Wear rate is very less. Okay, and also thermal, they can easily used in the where the high thermal applications, because they they are very less thermal expansion. If you increase 100 degree, they won't change its property. If you increase 500 degree, they may little bit change. But what happens to the steel? In the steel, if you change 60 to 70 degree, they start deforming steel. Okay, so these are the advantages of ceramic bearings. If you use ceramic bearings. Okay, and the following are the some of the examples of ceramic bearings. Here, zinconia oxide bearing. It's a one type of ceramic bearing. Okay, silicon nitride bearing. Silicon. Okay, silicon nitride. Silicon itself a very hard material. So silicon nitride, nitrates, oxides, and carbides of any metal is called ceramic material. Here you can see that zinconia oxide. Oxide is there. Okay, silicon nitride is there. Okay, so like this hybrid bearings. Hybrid means they are combination of two or more. So here a ceramic, steel, and chromium. If you use ceramic, steel, chromium combined, they become a hybrid ceramic material. And these are the some common basic components or properties of a ceramic material. First is a good thermal insulation. Good thermal insulation means they won't carry heat. Okay, they won't carry heat. Example example furnace is completely made by some sort of bricks. Correct, that bricks are completely what happens? Inside the furnace there is a high temperature, but if you see, if you touch outside the furnace, can you feel any temperature? You won't feel any temperature, but inside the temperature may be 900, 1000, 1500, but they won't carry the heat. They are thermally insulated. Okay, bricks. Clear? So that is a ceramic bricks. Those are all a ceramic bricks. Or else in the nuclear power plant, a control rod is there. Okay, have you heard control rod? That will control the combustion. That control rod is made by ceramic. Okay, and that entire furnace, inside the furnace is also made by ceramic. Okay, because in the nuclear there is a and fusion. There is a two process. By that two process, it generates a lot of heat. That heat may be 2000, 3000, 4000 temperature. Correct? So that entire chamber is made by a ceramics, so that these ceramics are withstand the temperature and won't deform. They won't lose its property at any high temperature. That is the one a good thermal insulation, a low thermal conductivity. They won't conduct thermal, they won't conduct heat. That's why they are insulator. They are used in the insulators. And resistance to the corrosion, resistance to the corrosion and acids. If you means they won't form any corrosion, they can use it in the water or any moisture conditions. They won't produce any rust, corrosion resistance. And also, if you any chemical reaction is there, in that also we can use it because they are neutral with the acids. They are neutral with the acids. These are all advantages. And of course, medium friction when compared to the metals, they are having a medium friction. And compared to the regular steel, they are medium friction. We can use up to 32,000 170 percent if we increase the speed also. When compared to the steel, they produce only medium friction. And lifetime 50% more than the steel. If you use steel, they may give life for 2 years. Okay. In the place of steel, if you use the ceramics, it increases by 50% means again another 1 year. You can get the extra life. Instead of 2 years, you will get the 3 years. So life increases, operating cost will decrease. And the resistance to the high temperature, and these can use for up to 500 degree temperature. Where the 500 degree temperature operation is there, we can easily use these type of doors. We can withstand very high temperature. And these are the advantages and disadvantages of ceramic bearings. If we have some advantages, obviously they are having some disadvantages. Here advantages is high hardness, high elastic modulus. If the high hardness is there, hardness is very high, wear resistance is very high, and so that wear rate is very low. Best example, you can take grinding wheel. So in the grinding wheel, wear is very low, correct? Grinding wheel. Or you can take this granites or stone. Stone wear rate is very low. Granite, you can use for 100 years, they won't wear, correct? Instead of granite, if you use any polymers or rubber, after 1 or 2 years, they will wear out, correct? Then high corrosion resistance, ability to run without lubricant, a low thermal expansion, low density. Density is low, that's why lightweight. They are used as lightweight. Density when compared to the metal, the density of ceramic is always less. And non-magnetic. They won't conduct magnet or electric. They are non-electric, non-magnetic. There, these are the advantages. And disadvantages, the ceramic bearing, the cost of ceramic bearing may be 2000 or 3000, but the ball bearing cost is 100 or 250 or 200. So see the cost, it may be 10 times or 20 times more. The high initial cost. A low load carrying capacity means if you go with a fatigue load or heavy load, they easily break because the ceramics are basically brittle. They are not ductile. Okay, they are brittle. That's why they are limited to the load. And sensitive to the thermal shocks. Thermal shock means sudden thermal shock. Again, if you apply the sudden thermal, of course, slowly increasing temperature means no problem. If you apply sudden means they are easily break. And difficult to achieve the high quality surface. When compared to the steel, you can get the mirror finish. Steel you can easily get the mirror finish, but you can't get in the ceramics. The mirror finish is not possible. Okay, they may have some waviness in the surface. That waviness may lead to the friction and weight. Clear? So these are the advantages as well as disadvantages of ceramic bearings. Ceramic used as a bearing material. Okay, so with this we finish off your non-metallic bearing material.